Hello class, here we are at Dr. Pano's lab and we are going to explain steel solvent distillation. So this is material that we have here. Here is the heat layer, this is our pot, this is the funnel, and this is the condenser.
So the second part of the steel solvent distillator, here is this machine that makes the water circulates all over the different distillators that we have. It's connected to 6 different, and it keeps the water cold.
These are the 6 solvent still distillators. Each of them is connected through a daisy chain from the water circulator down here. They're all sharing the same water, but they're not mixing together. These 2 distillators right here contain THF, which is also known as tetrahydrofurane. The reason these 2 are purple is because they were mixed with a pH indicator, because when the sodium reacts with the water, it creates a base. This distillator has hexanes and water, and the reason that the sodium looks like shoelaces is because sodium originally comes in metal blocks, chunks, so it has less surface area than it would be if it was in stream form. So in these 2, you see that the sodium looks that way, but these aren't purple because they don't need an indicator since the hexane is a hydrocarbon and it won't react with the water. This one right here contains toluene, and you can see inside the sodium looks like spherical, looks like little bubbles. And this one is clear as well because it won't react with the water. And this one is benzene. You can really see the sodium, but it looks like the hexane, the sodium inside the hexane. This is the machine that we use to turn these metal sodium cubes into the spaghetti-like form that you saw in the distillers.
Okay, the next step is to know how this method works. Here in our pot we will have the solvent, that in this case is the tetrahydrofurane, but this is a transparent substance. Why? Because it's dissolved in water, so we need to separate it from it. In order to do this, we will use 2 other substances. The first one is benzophenol. This will add a blue-greenish color to the substance, but not by itself. We need to add a metal piece of sodium that we have that you can see in here. Are those small ribbons that you see there? The sodium will react with the water and will form sodium hydroxide that eventually will turn out in a purple or bluish color. But if it is purple, the water is still reacting. Okay, the next step is to heat this thing. You will see at the beginning it is not moving, like in this one, but like in this one. But eventually, when things start to heat up, the vapor will go through here, go through here, and start going to this condenser. If you see, the condenser has some bubbles. Inside of those bubbles, there is the vapor that our substance is creating. Then now you will look through here. You can see there is water running, and also sometimes there is nitrogen added to make it colder. As we know, this will condense our solvent and go to here, the funnel.
Pues you can see the dropping there.
Go. Okay. Here we can see the funnel is full, so in order to prevent an explosion or something, it has this little thing again to make it go back to the pot. If you see here, we don't have the funnel full, so there is nothing dropping. The goal of this is that you split the water from the solvent. Here is the solvent, the tetrahydrofuran. And now you can collect it by only opening here and put your flask here. Okay, here we have a smaller sample of what we have in the system. This is the THF with the sodium and the benzophenol. You see that the sodium is the chunk in there. It's releasing bluish liquid. That's because it's forming the base, and with the benzophenol, that is a pH indicator, it will become blue.
Sodium isn't the only metal element that you could use to perform these tests. It can also be any other dry metal.